I prefer to get them the same. So I teach it more of a linear combination because you're just squishing them together. And that's where some people do call this the elimination method because you eliminated your y's at the very beginning. Okay? Oh. Okay, so first thing, go to y equals, get them cleared out. So go ahead and read that first equation to me, please. X cubed
Plus x squared
5x squared.
or 5x squared. Shouldn't trust him.
Uh-oh. X cubed, oh jeepers. Right. X cubed, now I have to get out of it, plus 5x squared
Plus 2x
plus 2x minus 4. Read the second equation to me, please.
x squared
X squared
plus 5x
plus 5x
minus 4.
minus 4. Thank you. So once you get those typed in carefully, you graph it. We're dealing with the cubic, which is S-shaped. You saw that come in here. And then we also have the quadratic, which is the U-shaped graph. And let's see if I get super fancy here. What's happening is right here, there's a whole mess of stuff. It's tough to even see what's going on. But I for sure see an intersection there. So you guys can find the intersection. You go second trace to calculate the intersection. Move the cursor so it's over there. But what's happening, and it's tough to see, is we're hitting here and we're hitting here. And the only point of doing this example in the lecture is to make sure you're paying attention. There could be more than one intersection. In this case, there are 3, and it's tough to see. Oh, I lost my calculator. So the thing you'd want to do here is with your window, maybe go -2 to 5, and let's see if we can see it. Even here we're having a hard time, but you can see there's a small gap there. -1 to 1. Still not the best, but we're zoomed in quite a ways. So that's the point of that problem. You guys can do that to finish it. All right, how many more we got left? These the last 2? Holy fuck it. That's the problem with P4 lectures, P5. We're pretty long on the lectures because there's so many different problems. All right, x to the 4th power can factor the same way you would a quadratic. We're going to go x squared and x squared in the front. Now, think about 12. 12 could be 1 and 12, 2 and 6, or 3 and 4. Those are the factoring. 1 and 12, 2 and 6, 3 and 4. Which one has a chance of getting me to 7? 3 and 4. So when that leading coefficient's 1, makes your life a little easier. So if I put a 3 in here and a 4 in here, because this is positive, I know it's a double sign. So it's either positive, positive, or negative, negative. What does it have to be so that we add up to -7? Negative, negative. Difference of squares. This one is probably the easiest for you guys to see. That's x squared minus what number squared? 4 is what number squared? 2. One has to, because this is negative 4 up here in the quadratic, one has to be positive, one has to be negative. So when you go to FOIL it out or multiply it out, you end up with the 2x term and the negative 2x term. And what happens when you put 2x and negative 2x together? 0. So that's why there's no middle term. So anytime you run into x squared minus a number, it's called the difference of squares, and you can factor it like we did. Not as obvious, x 3 is what number squared? 3 is what number squared? Square root of 3. So it's positive, negative of the square root of 3. So if this thing is set equal to 0, I have negative square root of 3, square root of 3, negative 2, and 2. We have 4 solutions there. X cubed. The only way right now you guys know how to solve x cubed is factor by grouping. Factor by grouping. We're going to be nice. We'll probably set it up perfectly so that the first 2 things can be grouped and the second 2 things can be grouped. What do x cubed and 3x squared have in common? Bunch of x's, right? So I can take an x squared out of both of them. Now, one of the things I watch is some students have difficulties with this x cubed and all this stuff. X cubed can be written as 3x's on the top. X squared can be written as 2x's on the bottom. And literally, when you factor the x squared out front, you are dividing. So what happens when you divide? What's left? So there's an x here. What's 3x squared divided by x squared? What's left? 3. So when you talk about factoring out, what are you dividing out of those terms? What do the negative 4x and negative 12 have in common? A negative 4. So what's negative 4x divided by negative 4? Just the x. What's negative 12 divided by negative 4? Positive 3. What do you notice about the parentheses? They're the same. Now, how many terms do we have in that blue, and how many factors do I have? How many terms do we have? 2 terms. 2. It's x squared, x plus 3 is one term. The 4 and the x plus 3 is the other term. So there are 2 terms. But they have a common factor, right? They both have that x plus 3. So what we're going to do is factor the x plus 3. We're going to divide that out to the front. So x plus 3 comes out front. What happens when you have x squared, x plus 3 divided by x plus 3? So again, when you factor it out front, what's left over? Just x squared. Do the same thing with the negative 4 and the x plus 3. If you pull the x plus 3 out, what's left? Minus 4. So you have x plus 3 and x squared minus 4. What did you learn about x squared minus 4? It's the difference of squares. So you have all those factors set equal to 0, you set each factor equal to 0, and I get -3, 2, -2. If you plug those numbers into the function, if you plug them into the original function, it'll make it 0. Last two. I'm going to pause it for a second to give you some time to work on this quadratic. The thing that makes it more difficult